Welcome to the exam review for Exam 2 for Biostatistics, and I'd like to point out a few things that we are going to focus on for this upcoming exam. And they fall into four main categories. Number one would be selecting the best test, and you've had a number of scenarios for that. Hopefully by now you can see how important that is both to CPH exam testers and to just generally your knowledge as you move out into public health, really understanding which tests fit certain scenarios. Next is the assumptions, and this falls into a couple of different categories. What are they? What are the assumptions for given statistical tests? And we only learned them for a few, and I'll point those out. But also, maybe given some bits and pieces of output, is that assumption met? And so that's the kind of thing that will be embedded in a longer scenario where they give you some information and they want to know if the assumption of equal variances, for example, is met. And so that would be a second piece of the information that you'll need to know for this upcoming exam. Third, you've had some exposure to this in the past, is interpreting results. So you would be given a scenario almost like the results section of a paper, and you would need to say, what is your interpretation? Do you reject the null? Does this mean that those two variables are or are not related? That kind of thing. But then also there's a sneaky kind of question, and this is really tied to the selecting the best test. They may give you some specific results, and one of the possible answers is they didn't run the correct test. They may give you the results from an independent t-test, but there were two continuous variables, and so they should have run a simple linear regression, for example. So one of the answers will say, you cannot make an interpretation from this data because they ran the incorrect test. So it looks like an interpretation question, but it's a did they select the best test kind of a question. So be sure that you're looking at that with a critical eye in terms of the test and its compatibility with the results that they're giving. Finally, we touched on confidence intervals, and the gist of the confidence interval is that the results from your confidence interval will always match the results that you're used to looking at in terms of significance levels or p-values. And so if your confidence interval, say for beta, does not include 0, then you would interpret that you reject the null hypothesis, for example. If your confidence interval does include 0 for beta, for your beta coefficient in your simple linear regression, then you would conclude fail to reject the null. And so those are the kinds of things with confidence intervals. Confidence intervals will always match up with your p-values, and so you can use confidence intervals instead of the p-value to interpret your results. And so you'll see a couple of confidence interval questions. So really quickly, let's go ahead and look at this selecting the best test, and I'll fill in some of the information here. The primary places that we'll be looking are the chi-square. We covered those in depth. And so you should be able to do all of these things in terms of chi-square, including selecting the best test, what are the assumptions, are they met, interpreting the results. Chi-squares don't have confidence intervals, so you wouldn't have something there to be interpreting. But then also the independent t-test, one-way ANOVA, and the simple linear regression along with Pearson correlation. So those tests we all learned kind of in depth in terms of these you would also be able to do selecting the best test, what are the assumptions, interpreting the results. We did not learn confidence intervals for the one-way ANOVA, but certainly for simple linear regression and independent t-test. And so those are the main areas. And in addition then, the one sample t-test, paired samples t-test, multiple linear regression, and logistic regression are added to that list of possible tests in terms of selecting the best test. And so I'm not going to ask you about assumptions for those additional tests. I won't ask you about interpreting results or confidence intervals for those. We didn't go into those in depth enough, just you got an exposure to them. And so let's take a look at the ones that we do know. For the chi-square tests, the assumption for that is, do you have an expected value of at least 5 for 80% of your cells, and an expected value of at least 1 for all of them? And so this is the realm of, for confidence intervals, of expected values. And so I could type that into every single box, but I'm not going to. That is just means that we have a large enough group within each of those cells that the number is somewhat stable. It's not going to be bouncing all over the place just because we have 1 more in that cell or 1 less. And so that's kind of a stability of the testing kind of a question. And you can look at the output, or you can see whether that assumption is met by looking at what the expected values are for any of the given cells. So for the independent t-test, if you remember, we have the assumption of independence, we have the assumption of normality, and we have the assumption of equal variances. And so with those 3 assumptions, then we would be able to know if the independent t-test is the best test for us to run. If the assumptions aren't met, what does that mean? That means that our test may not give us the correct results. And so it might say reject the null when we should have failed to reject the null, or it might say fail to reject the null when we should have rejected the null. And so having those assumptions not met means that when we're running the test, we can't be sure that the results that it gives us are really accurate. And so the assumption of independence really is dependent on how the sample was selected, and so that's not something that we can run a statistical test for. The assumption of normality, what I've taught you, is kind of the eyeball test. If you're looking at a histogram, does it look like it's a bell-shaped curve? It doesn't have obvious skew to the left or the right. It doesn't have extreme outliers. And so that assumption of normality means that it is falling into the distribution that we're normally used to seeing. And equal variances is tested by the Levene's test. So please review the Levene's test. I'll put Levene's on here. If we were to remind ourselves that both the independent t-test and the one-way ANOVA are very similar to each other, they're siblings, we can just copy and paste. The assumptions for these 2 are identical. And so given any type of scenario, both for a one-way ANOVA or for an independent t-test, the assumptions for those 2 will be evaluated in the same way. Now, for the simple linear regression or Pearson correlation, there's an extra one, which is linearity. And equal variances is not tested by Levene's test. It has another name, Homoscedasticity. I don't think it'll fit in there, but anyway. So our equal variances is homoscedasticity. Let's make sure it fits on the same line. And that is really whether the cloud distribution is evenly spaced as you go along the continuum. And so for simple linear regression, again, independence, normality of the residuals, equal variances are also known as homoscedasticity, and the important addition here is linearity. It's simple linear regression. So we're not testing whether there is a curved relationship between those 2 variables. We're testing for a linear relationship. And that would be if the cloud looks like it falls in more or less a straight line rather than a curved line. So that is kind of touching on the most important pieces of what we've learned this quarter. Wanted to make sure that you know exactly what kinds of questions we'll be looking for, and hopefully you'll be able to identify those as you go through the exam. There will be, I believe, 16 biostatistics questions on this upcoming exam, and so good luck with your review.